Alright, so in this problem, I have x to the power of x to the power of 4 is equal to 64. So I need to find the value of x here. So for my solution, I'm going to first start by taking the power of 4 on both sides. So now I have x to the power of x to the power of 4 to the power of 4 is equal to 64 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So I can switch the places of m and n here. So in this case, we can think of x to the power of 4 here as m and 4 as n. So if I switch the places of these two, I get x to the power of 4 to the power of x to the power of 4 is equal to 64 to the power of 4. Now I'm going to replace 64 with 8 squared. So now I have x to the power of 4 to the power of x to the power of 4 is equal to 8 squared to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So a to the power of 2 to the power of 4, that's going to equal a to the power of 2 times 4, which is equal to a to the power of 8. So I have x to the power of 4 to the power of x to the power of 4 is equal to a to the power of 8. Now I'm going to let x to the power of 4 equal to the variable y. So now I have y to the power of y is equal to a to the power of 8. And if I have something from a to the power of a is equal to b to the power of b, this means that a is equal to b, meaning y is equal to 8. Now remember how we let x to the power of 4 equals y. So if x to the power of 4 equals y and y equals 8, then this means that x to the power of 4 is equal to 8. So now to solve this equation, I'm going to take the fourth root on both sides. So the fourth root of x to the power of 4 is x, and so I have x is equal to fourth root of 8. So now to check, my original equation was x to the power of x to the power of 4 is equal to 64. X is equal to fourth root of 8, so now I have fourth root of 8 to the power of fourth root of 8 to the power of 4 is equal to 64. Now the fourth root of 8 to the power of 4 is simply 8, so now I have fourth root of 8 to the power of 8 is equal to 64. Now, this is the same thing as 8 to the power of 8 over 4 is equal to 64, meaning 8 to the power of 2 is equal to 64, and 64 equals 64. So this is right. Alright, so in this problem, I have x to the power of 3 plus x is equal to 10. So to solve this, I'm going to first start by subtracting 10 on both sides. So now I have x to the power of 3 plus x minus 10 is equal to 0. Now negative 10, that's the same thing as negative 8 minus 2. So now I'm going to switch the order of these and rewrite this as x to the power of 3 minus 8 plus x minus 2 is equal to 0. So now 8 is the same thing as 2 to the power of 3. So now I have x to the power of 3 minus 2 to the power of 3 plus x minus 2 is equal to 0. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, x to the power of 3 minus, x to the power of 3 minus 2 to the power of 3, I can rewrite as x minus 2 times x squared plus 2x plus 2 squared, which is 4, plus x minus 2 is equal to 0. So now if I factor out x minus 2, I get x minus 2 times x squared plus 2x plus 4 plus 1 is equal to 0, which is the same thing as x minus 2 times x squared plus 2x plus 5 is equal to 0. So now to solve this, I have two equations. I get x minus 2 is equal to 0, and x squared plus 2x plus 5 is equal to 0. So for x minus 2 equals 0, x is obviously equal to 2, so this is one solution. And for x squared plus 2x plus 5 equals 0, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, b is equal to 2. So I have negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 5, all over 2a, so 2. Now this is the same thing as negative 2 plus or minus the square root of 4 minus 20 over 2, which is equal to negative 2 plus or minus the square root of negative 16 over 2. Now the square root of negative 16 is the same thing as the square root of 16 times the square root of negative 1, and the square root of negative 1 is equal to an imaginary number I. So negative 2 plus or minus the square root of, square root of 16, which is 4, times I. I is the square root of negative 1 over 2, which is equal to negative 1 plus or minus the square root of 2i. So two more solutions. All right, so in this problem, I have 6 to the power of x is equal to 60. So to solve this, I'm going to first start by taking the log on both sides. So I have log 6 to the power of x is equal to log 60. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 6 to the power of x, and I can move x to the front. So now I have x times log 6 is equal to log 60. Now I'm going to divide both sides by log 6. So then these two cancel out, and now I have x is equal to log 60 over log 6. Now log 60, I'm going to rewrite as log 6 times 10. Now I have this over log 6. So if I have something in the form log of a times b, this is equal to log a plus log b. So log 6 times 10, that's going to equal log 6 plus log 10. Now I have this over log 6. Now this is the same thing as log 6 over log 6 plus log 10 over log 6. Now log 6 and log 6, these two cancel out. So now I have 1 plus log 10 over log 6. Now log 10, that's the same thing as 1. So now I have x is equal to 1 plus 1 over log 6. And log 6, we can rewrite that as log of 2 times 3. So now this is the same thing as log of 2 plus log of 3. And log 2, that's equal to 0.301. Log 3, that's equal to 0.4771. So x is equal to 1 plus 1 over 0.7781. Now 1 over 0.7781, that's equal to 1.2852. So 1 plus 1.2852 is equal to 2.2852. So this is my answer.